The Johnstone Supply Company Cafferty Group, located in Nebraska, Iowa, Kansas, and Colorado, presents VRV System Operation. This system is in simultaneous heating and cooling modes. As the refrigerant leaves the compressor, it is in a high-pressure, superheated vapor state. Its first stop is the oil separator. The oil separator is a spiral device that uses centrifugal force to remove oil from the refrigerant. The oil leaves the oil separator and passes through a solenoid valve on its way to the compressor. The solenoid valve is activated by the main control board when the system goes into an oil recovery mode. Oil recovery mode is activated when the compressor runs at low frequencies for a specific amount of time. It's at lower compressor frequencies where the oil separator is the least effective. The oil passes through the solenoid valve, then through a capillary tube to remove any liquid refrigerant that may be trapped in the oil, and then returns the oil back to the compressor where it belongs. Notice that the outdoor unit heat exchanger is divided into 3 separate compartments, each a different size, to more accurately control the amount of subcooling or superheat needed by the system. Also notice that the outdoor unit is equipped with 3 four-way valves. These valves are used to control the flow of refrigerant through the system to not only control the mode of operation, but also direct refrigerant to the correct sections of outdoor coil to accurately superheat or subcool. The refrigerant leaves the oil separator and passes through a filter or strainer on its way to the tube-in-tube heat exchanger, and then on to the smallest section of outdoor heat exchanger. This system is capable of taking some refrigerant off of the top of the liquid receiver, sending it through an expansion valve, and then directing it through the other side of the tube-in-tube heat exchanger to help subcool the refrigerant before it gets to the outdoor coil. As the refrigerant passes through the outdoor heat exchanger, it is subcooled into a liquid. As the outdoor unit runs, the inverter board will create heat in the section where the DC power is converted into a 3-phase AC to run the compressor. The outdoor unit refrigeration circuit directs subcooled liquid through a heat sink to cool that inverter board. Since the system currently is requiring more heating than cooling, this 4-way valve is directing refrigerant to the smaller of the 2 remaining sections of outdoor heat exchanger, reserving the larger section for the heating mode. So the high-pressure superheated vapor is also routed to that section of the coil where it too is subcooled into a liquid. The next 4-way valve will be shifted to direct the high-pressure superheated vapor indoors to the units that are calling for heat. The liquid refrigerant leaving the smaller section of the outdoor heat exchanger travels through the heat sink to cool the inverter board. The liquid refrigerant leaving the upper section of the heat exchanger and the liquid refrigerant leaving the heat sink both travel through an electronic expansion valve. The expansion valves are not metering the refrigerant, but controlling the flow through the outdoor coils to get the perfect amount of subcooling. The refrigerant from the heat sink will meet up with the refrigerant leaving the liquid receiver. The liquid refrigerant from the upper section of coil will travel through a series of check valves to be routed to the liquid receiver. The liquid refrigerant will be taken off the bottom of the receiver and will be sent to meet up with the liquid refrigerant coming back from the indoor units. The high-pressure saturated vapor will leave the outdoor unit on the high-pressure line and be routed to the indoor units that are calling for heating. The high-pressure vapor will be routed into the branch selector and then travel through an expansion valve which is pulsed wide open and not metering. It'll then be routed into the indoor coil. As the high-pressure vapor travels through the indoor coil, the refrigerant is being subcooled into a liquid and giving off heat to the space. The subcooled liquid refrigerant leaving the indoor coil is sent back through the branch selector and routed to the liquid line. which is then routed back through the branch selector boxes and sent to the indoor units that are calling for cooling. The liquid refrigerant entering the indoor coil passes through an expansion valve which will meter the refrigerant, causing a pressure drop, changing the state to a saturated vapor. As the low-pressure saturated vapor travels through the indoor coil, it is being superheated into a suction gas, removing heat from the space. The superheated suction gas is sent back to the branch selector box and routed through the low-pressure expansion valve to the suction line to be taken back to the outdoor unit. The refrigerant leaves the indoor branch selector boxes and is sent back to the outdoor unit on the liquid line and the suction line. The suction line enters the outdoor unit and is routed to the accumulator. The liquid line enters the outdoor unit and is routed through a series of check valves to meet up with the liquid refrigerant from the liquid receiver and sent to the indoor units that are calling for heating. The liquid refrigerant en route to the outdoor coil passes through an expansion valve, experiencing a pressure drop and changing the state of the refrigerant to a saturated vapor. The saturated vapor refrigerant is passing through the outdoor heat exchanger, collecting heat from the outdoor air, and superheating the refrigerant into a suction gas. The suction gas leaving the outdoor heat exchanger is routed through a four-way valve and meets up with the suction gas returning from the indoor units just ahead of the accumulator. The suction gas leaving the accumulator is routed back to the compressor to start the process over again. Here's an example of a multiple indoor unit branch selector box as opposed to the single indoor unit branch selector box. You can see that the operation is basically the same, but it will accommodate up to 12 indoor units on one branch selector box. Thank you for joining us on this journey through a VRV system in simultaneous heating and cooling modes. We hope you found this informative and helpful. If you would like more information, please contact us at any of the Johnstone Supply Cafferty Group offices.